Hi, everyone. Welcome to my talk today about modernizing government ID with cloud-native virtualization. I'm Michael Tillman, and so let's go ahead and get right into it, shall we? This is me. I'm Michael Tillman. I'm the manager of the North and South American Solution Architecture team here at Mirantis. Just a little blurb about me. I've been in this industry for about 15 years, and I'll let you read that if you like. But today, what we're talking about, honestly, is government IT and cloud native virtualization. Today, the agenda is a couple of things: the role of cloud native virtualization and reducing the operational complexity of their IT infrastructure. The strategies for achieving scalability and improving service efficiency, real world insights into how you can overcome these legacy system challenges. And then at the end, some best practices for implementing secure, future proof, future ready infrastructure. So imagine a world where government services are as seamless as your favorite streaming service. No long wait times, no outdated systems crashing when demand spikes, just fast, reliable, and secure access to public services. Some of the relevance and importance of this is governments the world over are under immense pressure to modernize and update their IT infrastructure to meet everyone's growing demands. Legacy systems are often complex, they're very costly, and they're generally unable to scale efficiently. Cloud native technologies, and specifically the Mirantis Kubernetes Engine, MKE, and MKE with KubeVirt offer a viable solution to these challenges. Let me talk, number one, about the problem. The problem is the legacy government IT challenges. And what do I mean when I say legacy? There's a couple of things, right? And the common challenges that are associated with this are aging infrastructure, the high operational costs, security vulnerabilities, and then limited agility. So the aging infrastructure is not something that I have to go very far into. It's old and antiquated. It's very difficult to maintain, and it's almost near to impossible to scale. High operational costs are due to these inefficiencies, and more specifically, they're very tied to vendor lock-in. Security vulnerabilities that expose critical government data, that's something that we cannot and will not tolerate. But those security vulnerabilities are something that we'll take a look at in just a second as well. But the limited agility is the ability to respond to emerging system needs and their crises. So let's talk just real quickly about one of the case studies that I did and that example. So what I did was I pulled up a state government agency that is responsible for the public benefits administration, and they were struggling to keep up with the public's demand with their outdated IT systems. So what were the challenges that they faced? There were quite a few, but I narrowed them down to the four that you see on the screen now. There was slow processing time, frequent downtime, security risks, and limited scalability. So what are the slow processing times? The benefited applications that I looked into took weeks to process due to a monolithic system that required a significant amount of manual data entry. And what I mean by that is that any type of request that came in through their system, it came in a paper format, and it was required by the employees to manually input this data into an antiquated system. And from that system, then it needed to, there were not only manual physical errors of that transfer of data, but there was also an extensive amount of time that as they were inputting the data, it just takes a long time for people to actually input the data into the system, and it just took an extensive amount of time. The legacy mainframe infrastructure experienced outages, causing disruption, And when the system was down, obviously you can't input data, you can't receive data, and you can't send data. So the legacy mainframe, it was the main problem that was required for this government subsidy to basically have anything up. And the security risks, again, it's an outdated system, greater than N+2. So the outdated system lacked modern encryption, and it didn't have the proper access control measures, and it was basically exposing customer sensitive data. Limited scalability was the system basically just could not handle the increased demand. So especially during a crisis period and when there was economic downturns, there was just no way for the system to be able to handle the need that was input from not only the public, but from the data input people as well. So what's the impact of all of this? Obviously, there are delays in the disbursement of assistance. Obviously, the IT teams were overwhelmed. And then in addition to that, there was also pressure on the actual agency itself. So citizens experienced these delays in receiving the essential services that they needed, such as unemployment benefits or healthcare coverage. The IT teams were overwhelmed with maintenance tasks, leaving little to no time for innovation or proactive improvements. The agency faced increasing pressures from regulatory bodies to improve the security and, more importantly, the service reliability. So, how do legacy systems increase your operational risks? A couple of things that I want to talk about specifically is downtime and service disruptions. Older IT systems often rely on not only outdated hardware and software, but that makes them prone to unexpected failures that disrupt their essential government services, such as public health care, emergency response, and tax processing. The lack of support and maintenance. So many legacy systems are no longer supported by vendors, and that leaves governments with security gaps and increasing need for costly custom maintenance. Scalability challenges. Legacy infrastructure cannot easily handle the sudden spikes in demand, such as a surge in unemployment and the unemployment claims during economic downturns, or an influx of voter registration before elections. Data silos and inefficiencies. Legacy systems often operate in isolation, preventing seamless data sharing between agencies and creating inefficiency in service delivery. The impact of outdated technology on citizen services and workforce productivity. So let me talk just real quickly about that. And I have 4 pieces here that I'd like to speak specifically about, and that's slow and inefficient service delivery. So long and processing times for benefits applications, outdated user interfaces for public portals, and manual workflows cause huge delays and frustration for the people that they're covering or trying to cover. Cybersecurity risks. Obviously, older systems lack modern security measures such as zero trust, automated threat detection, and increasing the risk of data breaches and cyber attacks on that critical infrastructure. Again, higher operational costs, and a lot of that is maintaining legacy infrastructure. It's so expensive due to a couple of things. Number one, high energy consumption, complex dependency chains, and more importantly, the need for specialized personnel to manage these outdated technologies. Workforce limitations. Of course, government employees are forced to work with outdated systems that lack automation, slowing down productivity and making it difficult to attract and retain skilled and proficient IT professionals. wherever there's a problem, there has to be a solution, right? So the solution here in this case that I'm talking about today is cloud native virtualization. What does it mean to be cloud native? There's a lot of varying responses to that, but I'll tell you just by definition what it means to be cloud native. And cloud native refers to designing, developing, and managing applications using cloud infrastructure to maximize scalability, resilience, and more importantly, automation. Microservices architecture. So instead of having monolithic applications, cloud native systems are broken down into smaller, independent services that can be developed, deployed, and scaled independently. So, for example, a government website with separate services for identity authentication, data retrieval, and payment processing. Containers and Kubernetes. Cloud native applications leverage containerization that ensure portability across environments, managed efficiently using Kubernetes. So an example of this is a government tax filing system running as a set of containerized services, ensuring uptime even during peak seasons. So a very important aspect here is DevOps and CI/CD pipelines. Automation of deployment and integration processes for continuous updates and security patches. So for example, public transportation API receiving frequent feature updates without any type of downtime. The next topic, resiliency and self-healing. Obviously, this is a very important part of Kubernetes and containerization, but cloud-native platforms use self-healing capabilities where services restart automatically if they fail. So, for example, voter registration system that auto-recovers from crashes without any type of manual intervention. And last but not the least, API-driven communication. This is very important because cloud-native applications communicate through well-defined APIs, allowing easy integration with third-party services. And a very simple example of this is a government application integrating with the private sector via identity verification providers. So why Mirantis, right? The Mirantis Kubernetes Engine and the Mirantis Kubernetes Engine with KubeVirt. So just a couple of things here and why MKE for cloud native adoption. There's quite a few things, but I want to talk around 6 of them or so. So first and foremost is automated Kubernetes management. MKE simplifies Kubernetes operations by automating deployment, scaling, and lifecycle management, reducing the burden on government IT teams. We provide multi-cloud and on-prem support. MKE allows government agencies to deploy workloads across private data centers and public cloud providers such as AWS, Azure, and GCP, providing flexibility and avoiding the vendor lock-in. Security and compliance. This is a very big and very important part, but MKE meets strict government security standards such as STIG and FIPS 140-2, ensuring that applications and citizen data remains protected from cyber threats. Enhanced CI/CD capabilities. Government developers can leverage MKE's integration with DevOps tools to accelerate their service delivery while maintaining security and reliability. Of course, where would we be without any type of high availability? And more importantly, the disaster recovery. Built-in high availability ensures government applications remain accessible even during outages, while disaster recovery features help that agencies can quickly restore critical services. And then at the very end here is observability and monitoring. MKE integrates directly with tools like Prometheus and Grafana for real-time monitoring, providing government IT teams with deep insight into systems health and performance. So with all of that being said, let me talk now just quickly about MKE with KubeVirt for your hybrid workloads. Seamless virtual machine and container integration is something that is very relevant and government agencies can run both your legacy VM-based applications and your modern containerized applications side by side on Kubernetes, enabling the gradual migration if that's the way that you choose. If you are wanting to migrate off of the traditional virtual machine-based applications to a containerized application, then we can enable that in a side-by-side environment. Cost savings and efficiency by consolidating VMs and containerized workloads onto a single platform, agencies can optimize resource utilization and reduce infrastructure costs. Automating, scaling, and self-healing. Of course, applications running in KubeVirt benefit from Kubernetes native self-healing, auto-scaling, and workload orchestration, improving uptime and reducing the ever-dreaded manual intervention. Enhanced security for hybrid environments, and that is KubeVirt ensures that VM workloads benefit from the same security policies and network segmentation and access controls as containerized applications. Legacy applications modernizations. So government agencies can containerize portions of legacy applications while keeping essential VM-based components operational, reducing the modernization risk while increasing agility. So one of the use case examples of this is a city transportation department migrated its legacy VM-based traffic monitoring system into KubeVirt while simultaneously deploying new AI-powered analytics services in Kubernetes, ensuring real-time insights without disrupting the existing operations. So two very powerful use case examples there, and showing why you would choose Mirantis and the Mirantis Kubernetes Engine to integrate into your solution. Some best practices for government IT and modernization. So how would you do it? How would government ITs modernize their applications, their infrastructure, etc.? Start small and scale fast. Prioritize security and compliance. Leverage automation, that's a huge one. And my favorite, future-proof your investments. And then, of course, cultural and organizational change. So let me talk about each one of these, starting from top to bottom. Start small and scale fast. So begin with pilot projects before committing to full-scale deployments to mitigate the risks and demonstrate the value in this endeavor. So one of the examples of this would be a municipal government first started migrating a single citizen portal before expanding cloud-native services across multiple departments. This approach allowed testing of the new technologies in a controlled environment, reducing the risk of major failures. Governments should adopt an iterative approach, continuously refining the process based on feedback from not only their IT teams, their developers, but the end users as well. Prioritizing security and compliance. So this is also very important, but you should ensure that your solutions align with the government regulations such as FedRAMP, FISMA, and GDPR to protect sensitive data. So an example of this would be implementing a IAM or identity and access management, zero trust security models to safeguard citizen data by enforcing some sort of role-based access control or RBAC. Agencies can limit exposure to cyber threats and ensure compliance with security mandates. Government agencies should also integrate security tools like running protection for containers and vulnerability scanning in CI/CD pipelines to detect and mitigate risks early. Leveraging automation. I think this is a very big one and very important, but the use of Kubernetes and Kubernetes native tools for automated management, including infrastructure as code for repeatable deployments. A very relevant example here is a state government using GitOps workflows to automate software rollouts and minimize human error. How did they do this? By leveraging automation. They can enforce consistently across deployments, reducing downtime, and more importantly, the manual configuration errors. By implementing self-healing infrastructure with Kubernetes ensures that if a service fails, it can be automatically restarted or scaled up with any type of manual intervention. Future-proofing investments. This is also very important because, as we know right now, this is with collapsing budgets. I think this is very important and very prudent at this point. But you should be able to choose flexible, vendor-neutral technologies like MKE to prevent lock-in and allow seamless integration with emerging technologies. You should also future-proof by adopting open standards and APIs that facilitate interoperability between different government agencies and the private sector partners. So a big one that may or may not be controversial, but cultural and organizational changes. Address the resistance to modernization by promoting education, training, and more importantly, leadership buy-in. So one thing is to establish a CCOE or a Cloud Center of Excellence within your IT departments to lead digital transformation efforts. A CCOE provides best practices, governance, and mentorship to help teams navigate the shift to cloud-native technology. Providing incentives and upskilling opportunities to ensure that your staff can efficiently manage cloud-native infrastructures. And government should invest in training programs and certification for Kubernetes, DevOps, and cloud security to prepare your teams for modern IT operations. And again, encouraging independent collaboration through cross-functional teams to streamline the digital service implementation. This also reduces the silos and ensures that your team and your business stakeholders work together to achieve your common goals. So in conclusion, quite a few key takeaways here in this conclusion. Cloud-native virtualization is a game changer for government IT teams. It allows government agencies to modernize their infrastructure while maintaining cost control, security, and performance. MKE simplifies Kubernetes adoption and operations by automating the lifecycle management, security compliance, and multi-cluster management. MKE enables your teams to deploy, scale, and manage applications with minimal operational overhead. MKE with KubeVirt supports hybrid workloads, and government agencies can run traditional virtual machines alongside cloud-native applications, ensuring a seamless transition without disrupting existing critical services. Security and compliance are already built in. MKE's compliance with governmental security frameworks, combined with its integration with your identity and access management tools, ensures that government agencies can meet regulatory requirements while improving operational efficiency. MKE adheres to FISMA and FIPS 140 standards, ensuring that regulatory compliance is in effect. It also offers robust role-based access control and zero trust security models to protect sensitive government data. Improved disaster recovery and high availability. MKE ensures that government services remain online during crises by leveraging Kubernetes built-in failover, replication, and self-healing capabilities. It also supports multi-cloud disaster recovery strategies to ensure continuity of essential services. Future-proofing and scalability. MKE provides a foundation for emerging technologies such as AI, machine learning, and data analytics. Agencies can build new services faster, ensuring that IT investments continue to deliver value over time. If you're looking to modernize your government IT with scalable and secure solutions, now is the time to explore cloud-native technologies. Let's work together to build the future of public services. And please, at any time, you can reach out to me, Michael Tillman, mtillman at mirantis.com. And thank you very much.